In problem 969, we are given a wind tunnel that skydivers often use for practicing, and they want us to find the speed of the wind required in order for the skydiver to free float in the wind tunnel for when he is in both a curled up position and lying out flat. From a free body diagram where the simple circle represents the skydiver, we know that the only forces acting on the person in this scenario are his weight and the lift force from the wind, which leads us to conclude that for steady flight, the weight must equal the lift force. So using the equation from the book on lift, knowing that the coefficient of lift is equal to the lift force divided by 1/2 the density of the air times the velocity squared times the area, and using the table from the previous section in the book, which gives us the coefficient of drag times the area of the two conditions necessary to be 2.5 and 9 feet squared, we can come over here and modify this equation, moving the area over to the left-hand side and then plugging in the value from the table. And then what we have left is the lift force divided by 1/2 the density times the velocity squared. Coming on across, you can solve for the velocity squared, plugging in the weight of the skydiver as the lift force, because with changing the units, knowing that a pound is 1 slug times a foot per second squared, and then when you plug in the other units that you are given, your answer will be in feet per second. And for the case where the skydiver is curled up, you can find that the speed is 224 feet per second, which is about 153.1 miles an hour. Then for part B, for lying flat, you go through the exact same process, only you use the 9 for the coefficient table, and you plug it in. Using the same solving process, you can find that the velocity is 118.35 feet per second, which is approximately 80.9 miles an hour.